Hey everyone. My team works with mobile devices, handheld devices, and recently we had an issue where there was an overheating and melting of some power components, charging and cable and ports, and that actually reminded me of a concept called dirty electricity. And I'm not talking about fossil fuels or green energy or whatnot. Dirty electric is when the electricity that you are getting is not perfectly sinusoidal. So when alternating current is produced, basically it's a generator spinning across or through a magnetic field. So then the amount of flux it cuts at any point of time is equal to the sine of the angle. So when it is perpendicular, it's cutting all the flux. When it is parallel, it is cutting no flux. But at any point of time, it's sine x of the angle times the flux that it's cutting. So that's why when you get alternating current at 50 hertz or 60 hertz, it's supposed to be a perfect sine curve. What happens is, as the electricity is transmitted through various components, transformers, cables, overhead, high tension lines, a lot of harmonics are introduced into in that electric, right? There are harmonics of other higher frequency. There is resonance between different cables running together. What it does is it distorts the perfect sine curve, and it becomes a combination of multiple curves, some sine, some otherwise, and instead of getting a sine, you get like, and that's called a dirty energy, because when you try to consume it via transformer, for example, it generates a lot of heat because of the magnetic core, and the components that are built within that transformer are optimized for a certain frequency and certain amplitude. And since the electricity that you are using is not conforming to that standard, it creates excessive heat, and it's not good, right? One way to test that is, if you have a laptop charger, make sure your laptop is near empty, so say 20% or so, and plug it in at your home and leave it for about 10 minutes and look at how hot the brick gets, the part that holds the transformer, and then do the same experiment in your office. Generally, the commercial establishments and office, etc., the electricity goes through a lot of stabilizing circuits, and it's much cleaner. So your brick will heat much faster in your home if you have dirty electricity, compared to your office, where you most likely will have clean electricity. So a lot of times you have to keep that in mind, especially with the sensitive components. You have to have some sort of stabilizing circuits. I remember back in the 80s and 90s, when the TV was introduced in India, it was very standard for every TV to have a stabilizer circuit, because not only the frequency was bad, but also the amplitude would vary greatly. The RMS voltage value, the voltage that you will get, would be not necessarily the 220 volts that was expected, but it would fluctuate, and that would cause the TV to heat up and get destroyed. So it was easier to put a stabilizer circuit in front of it and then give the clean energy to the TV. In those days, it was really bad power transmission, and nobody cared to fix, because we had other priorities. As long as you got the lamp lit up and the fan running, we were okay. We moved on to do other things, because there were other infrastructure needs. We didn't have any electronics. TV was probably the most advanced piece of electronic, and with a stabilizer circuit, and even sometimes you would have the UPS, so it didn't shut off abruptly. It would work, but the whole concept was stabilizing your electric. So what happens is, if you have a mobile device, you generally use a USB-C or a micro USB cable to connect it to a wall charger, a small brick, and that goes into your outlet. If your home electricity is bad, and if you have a good charger, reputed, Samsung or Panasonic or one of those, even if it's a bad electric, the brick should clean it and send clean DC current, DC direct current to the device. So the device should not feel the brunt of bad electricity. That is, in general, the concept or the belief. However, if either the cable is too long or the contacts are not optimal, or what else? Yeah, I would say those are the two reasons where the device may not get charged properly. Either it draws excessive current, more than it should, it can on that setup, or it fluctuates between high speed charging and low speed charging. That could cause heating and even melting fire kind of issues. On the topic of charger itself, if you have a USB charger, USB operates at 5 volts, and in DC, direct current, power is simply the product of voltage and current. In AC, you also need to take care of the power factor. If there is any magnetic component, your current is going to most likely lag behind the voltage, and you won't get the complete power. Anyway, in DC, if you have a 2 amp charger at 5 volts, 2 times 5 is 10, so you can have a 10 watt charging. If your device can use, say, 25 watts at high speed charging, if the charger is only providing 2 amps, the device should switch to low speed charging and take only 10 watts at a time. So generally the devices are smart enough to do that. Generally the chargers are smart enough to control the amount of current flowing through it, but there are quality issues, there are design issues. Sometimes it does happen that you have a charger that is capable of only 10 watts, and if you put a high performance device on it, it starts drawing more current and your charger blows up. So shouldn't happen. The charger designer should take care of those things into account, but we all make mistakes. So alright, that's all it is.